Have you ever been caught driving in a total downpour? You know, where your wipers are going a mile a minute and you're still squinting to see? And you think to yourself, how is this entire road not a lake right now? Well, it's not luck, and it's definitely not magic. It's a pretty amazing feat of engineering, and it's all guided by this one document that almost nobody knows about, the Korean Design Standard. So today, we're going to pull back the curtain on this unsung hero of our daily commute.
Okay, just picture it. Rain is absolutely hammering your windshield. Water is starting to pool up on the asphalt, and that really scary thought of hydroplaning starts creeping into your mind. Right at that moment, there's this invisible battle being waged. It's a fight against physics, fought with concrete and steel, and the one single goal is to get that water off the road, away from your tires as fast as humanly possible.
So, where does the strategy for this whole battle come from? Well, it's all laid out in something called the Korean Design Standards, or KDS for short. The best way to think about it is like an official playbook for civil engineers. It's this super detailed guide on how to manage the complete chaos of a storm to keep our roads working and, way more importantly, to keep us safe.
And the mission statement here is just crystal clear. Its whole purpose is to prevent accidents and keep the roads functioning. And you know, this isn't just about avoiding a few traffic jams. We're talking about protecting lives and the massive, massive public investment that our road networks represent. Every single gutter, every drain, every pipe, it all serves this one fundamental goal.
All right, so let's follow the journey of one single raindrop. The second it smacks onto the asphalt, a clock starts ticking. If it hangs around on the surface for too long, it teams up with billions of other raindrops to create those super dangerous pools of water. So the drainage system's number one job? Get it off the road, and fast.
So how does this whole thing work? Well, first off, that raindrop doesn't just sit flat. The road itself is engineered with this really slight, almost unnoticeable slope. It's called a crossfall, and this gentle angle is just enough to push the water towards the edge of the road, right into a gutter. From there, it gets funneled into a catch basin, which is basically the gateway to the entire underground pipe network. It's a really simple, super elegant, and incredibly effective first line of defense. And engineers, they have a whole toolkit for this part of the job. They use different kinds of gutters, like L-types for your standard road edges, or these deeper U-types for places that have to handle a lot more water, like a highway interchange. And for those really critical spots that have to drain like right now, they can install these high-efficiency linear drains. Every single component is picked specifically for the job it needs to do.
But here's the thing, that surface toolkit, it can't catch everything. Some of that water is going to seep down through tiny little cracks in the pavement, down into the layers of gravel and soil that are actually holding the road up. And this is where a much sneakier, more insidious threat begins.
You see, water is the absolute number one enemy of a road's foundation. When all the soil and gravel underneath, that's called the subgrade, gets totally soaked, it loses its strength. It just can't support the immense weight of traffic anymore. And that is what leads to potholes, cracks, and eventually the whole road failing. So the real challenge isn't draining the water you can see, it's draining the water you can't.
And the solution is pretty ingenious. It's this hidden network of perforated pipes called Mang-am-kyo in Korean, which kind of translates to a blind ditch. These things act like arteries running just beneath the skin of the road, collecting and channeling away all the water that seeps down. This is the secret weapon that keeps the road's foundation dry, stable, and strong for decades.
Of course, a raindrop's journey looks totally different depending on where it falls. One that lands in the middle of Seoul faces completely different problems than one that lands on a steep mountain pass. So the engineering playbook has to have a different chapter for each of these scenarios.
In the city, the big problem is volume and speed. Water can't soak into concrete, right? So it all runs off at once, and it threatens to completely overwhelm the system. That means you need massive pipes and really powerful pumps. But out in the mountains, the danger is force. Rushing water can trigger erosion and even landslides. So the structures they build out there have to be way, way tougher, designed to handle not just water, but rocks and mud too.
So how do engineers decide how big or how tough to build everything? Well, they use this really cool concept called design frequency. This isn't about trying to predict next week's weather, it's more like playing the odds over the long term. When they design for a 50-year storm, they're building a system that can handle a downpour so intense that it only has a 1 in 50 chance of happening in any given year. It's all about risk management.
And this table from the KDS shows you exactly how that risk analysis plays out in the real world. Check it out. The big major pipes in high-risk mountain and urban areas, they're built to that 50-year storm standard. Now compare that to a general, flatter road, which is only built to a 30-year standard. It makes perfect sense.
The greater the potential for disaster, the higher the level of protection you build in.
And the planning gets even more granular than that. Just look at the simple surface drainage, the gutters and stuff. Mountain roads are designed for a 20-year storm, which is double the standard for urban roads. And the reason is simple. The consequences of failure are so much higher. Uncontrolled water rushing down a steep slope could be absolutely catastrophic.
So, as our little raindrops journey comes to an end, it's pretty clear we're not just talking about some pipes and ditches here. This is a huge, comprehensive, and, this is the important part, a living master plan for managing water. It's one that is constantly being tweaked and refined.
I mean, the first national standards were set up way back in 2001, but they didn't just write them and walk away. They've been revised over and over again, with major updates happening every few years. Each time, they incorporate lessons learned from past floods, they adopt new technologies, and crucially, they reflect a better understanding of our changing climate.
So the big takeaway is this. The next time you're driving and you see a gutter or you go over a drain in the road, just remember that what you're seeing is only the visible tip of this huge intelligent system. It represents decades of accumulated knowledge, all of it working silently in the background to get you where you're going safely, whether it's pouring rain or bright and sunny.
But this playbook is never truly finished. Even the standards themselves talk about the need to consider an abnormal climate. So the real question we're left with is this. As climate change makes those 50-year storms start to feel a lot more like 10-year storms, how is this playbook going to have to evolve to keep us safe on the roads of the future?